Hello friends, welcome to Susan and John MathTube. In this video, we are going to find the radius of curvature for some special problems. Okay, so the first thing we are going to focus is radius of curvature at the origin. Now listen very carefully, I'll make it very short. If x-axis is the tangent to the given curve, if x-axis is a tangent to the given curve, then radius of curvature is given by the Newton's formula, limit x tends to 0, y tends to 0, x square by 2y. Similarly, if y-axis is a tangent to the given curve, then the radius of curvature at the origin is given by the Newton's formula, limit x tends to 0, y tends to 0, y square by 2x. Now in the case where both x-axis and y-axis are not tangents, then what we do is we will apply Maclaurin's formula, the Maclaurin series, y equal to px plus qx square by 2 plus etc., where p stands for the first derivative at 0 and q stands for the second order derivative at 0. Okay, now another question. How to find whether x-axis or y-axis is a tangent at the origin? That's very easy. That's very easy. In the given equation, you find the lowest degree terms and equate it to 0. You find the lowest degree terms in x and y and equate it to 0. And that will give you the equation of tangent at the origin. Okay, let's do one example and try to understand. Okay, so please write the question. Find the radius of curvature at the origin for the curve 3x square plus 4y square is equal to 2x. Okay, I can notice one very interesting thing. That is, this curve will pass through the origin. I am 100% sure. Because 0, 0 will balance it. If you put x equal to 0, y equal to 0, the equation will be balanced. Anyway, we are not worried about that. My question is the x-axis or y-axis the tangent at the origin? So how do you find the tangent at the origin? Very simple. You find the lowest degree terms in x and y. Degree 2, degree 2, degree 1. So the lowest degree term will be 2x. Equate it to 0 and simplify. What is x equal to 0? The y-axis. So it is clear that our curve has tangent our y-axis. So the radius of curvature is given by, look at this, you can check the formula once more. Look, if the y-axis is the tangent, then the radius of curvature at the origin is given by, so limit x tends to 0, y tends to 0, y square by 2x. Okay, now what we do is, we create y square by 2x in this equation. And of course, in this example, it is very easy. All you have to do is you have to divide throughout by 2x. So 3x square by 2x plus 4y square by 2x equal to 2x by 2x. That is 3 by 2 into x plus 4 into y square by 2x is equal to 1. Now what we do is we will take this limit. Limit x tends to 0, y tends to 0, 3 by 2x plus I am going to take limit term by term on both sides. Now limit x tends to 0, y tends to 0, 4 into y square by 2x is equal to limit x tends to 0, y tends to 0, 1. Now look at this. If x tends to 0, this will become 0. 3 by 2 into 0 is 0. Plus 4 is a constant. This will come outside. And the remaining part will be rho. and limit of a constant is the constant itself. So I get 4 rho is equal to 1. So rho is equal to 1 by 4. See, it's so easy. Okay, let's try one more problem. Please write the question. Find the radius of curvature at the origin for the curve 4x square minus 3xy plus y square minus 3y equal to 0. So look at this, degree 2, degree 2, degree 2, degree 1. So the lowest degree is 1 and there is only one term of degree 1. I am going to equate that to 0. And that gives me x-axis. So did you understand the shortcut to find the tangent at the origin? Very simple. Find the terms which has the lowest degree, equate it to 0. Okay, so clearly x-axis is a tangent. So the radius of curvature is given by limit x tends to 0, y tends to 0, x square by 2y. The trick to remember the formula is, if x-axis is a tangent, you remember x square will come. And if y-axis is a tangent, then y square will come. Yeah. Okay. So you can keep this somewhere. Let's put a box. Now look, I'm going to divide throughout by 2y. So 4x square by 2y minus 3xy by 2y plus y square by 2y minus 3y by 2y is equal to 0 divided by 2y, that will be 0. Okay. Now let's simplify a little bit. I think this will get cancelled, this will get cancelled, this will get cancelled. So now let's do one thing. Take limit throughout the expression. So limit x tends to 0, y tends to 0, limit x tends to 0, y tends to 0, limit x tends to 0, y tends to 0. Write very neatly in your exam. Don't write like this. Okay, anyway, what is this? This will give you 4 times rho minus 3 by 2 into 0 will be 0 plus 1 by 2 into 0, that will also be 0, minus limit of a constant will be the constant. So I got 4 rho is equal to 3 by 2. So what's the radius of curvature at the origin? 3 by 8. Isn't it easy? Yeah. Okay, now let's go for the next question. Find the radius of curvature at the origin for the curve. So what we do is very simple. First we find the tangent, equation to the tangent at the origin. So degree 3, degree 3, degree 2, degree 1. So degree 1 is the smallest, and equating that term to 0, I get x-axis to be the tangent at the origin. So our radius of curvature is given by the formula limit x tends to 0, limit y tends to 0, x squared by 2y. So I am going to divide throughout by 2y, x cube by 2y plus y cube divided by 2y minus 2x square by 2y plus 6y by 2y is equal to 0. The first one I am going to write x times x square by 2y, because I am creating this x square by 2y, plus here it is 1 by 2 into y squared, and here it will be 2 into, don't touch that, don't cancel that 2 because we need that 2y here, plus 3 is equal to 0. Now taking limits on both sides, in your examination you have to show that step, limit, 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 limit. So this becomes 0 into rho, that will be 0, plus 1 by 2 into 0, minus 2 times radius of curvature plus 3 is equal to 0. So I got 2 times radius of curvature equal to 3, so radius of curvature equal to 3 by 2. Now one very important question. Find the radius of curvature at the origin for x cube plus y cube equal to 3axy. So look at this. This passes through the origin. Degree 3, degree 3, degree 2. So lowest degree is 2. I am going to equate that to 0. 3 is a constant, a is a constant. So I will get x equal to 0 or y equal to 0. That means both x-axis and y-axis are tangents. So that means both x-axis and y-axis are tangents. So this time I am going to divide throughout by 2xy. And anyway, I am going to use the formula. You can use both formulae. I am going to use the formula for x-axis being a tangent, that is x square by 2y. So I will divide through, since both are tangents, I am going to divide by xy. I have to divide by xy, otherwise you will never get the answer. Always keep that in mind, because both x-axis and y-axis are tangents. You have to divide throughout by x into y. Anyway, I am going to have more profit by dividing by 2xy plus y cube by 2xy is equal to 3a by xy, and here 2xy. So we will get x square by 2y plus, so here we have a problem, we will get indeterminate form. So we get y square by 2x. We will think about it in the next step. Can you see, we will get indeterminate because both x and y tends to 0, we will get 0 by 0. If you want, you can use L'Hopital, but it will be better to make it. Okay, I am going to create that radius of curvature. So I will put x square here. I will write x as a compensation by 2y here, and I will write 2y here as a compensation. So I will get x square by 2y plus x into y into 1 by 4 into x square by 2y is equal to 3a by 2. Okay, now take limits. In examination, you have to write limit x tends to 0, y tends to 0, limit x tends to 0, y tends to 0, limit x tends to 0, y tends to 0. So what's this? Rho plus 0 into 0 into any count, that will be rho. So that is going to be 1 by 4 rho is equal to 3a by 2. That's it. So radius of curvature is 3a divided by. Now another question. So find the radius of curvature for y square is equal to x square multiplied by a plus x the whole divided by a minus x at the origin. So the first thing I am going to do is I am going to simplify this and find the tangent at the origin. So I get a y squared minus x y squared minus a x square minus x cube equal to 0. So you can see degree 2, degree 3, degree 2, degree 3. So we will equate degree 2 terms to 0. So y square equal to x square, y equal to plus or minus x, y equal to x, and y equal to minus x. So clearly our curve has two tangents at the origin, but it is not the x-axis, it is neither the y-axis. So remember, Newton's method will not work. X-axis is not a tangent, y-axis is not a tangent. So Newton's method will not work. So what do? In the beginning itself I told you we will use Maclaurin series at the origin. That is, we will plug in y is equal to px plus qx square and find p and q. So please write, since x-axis and y-axis are not tangents at the origin, we cannot use Newton's method. So let y is equal to px plus qx squared by 2 plus etc. where P means derivative, first derivative at 0, and Q means second order derivative at 0. Now what we do is we will plug this into the equation. We will plug it here. It will be comfortable to plug it here. So we get a minus x into y squared. So px plus q x square by 2 plus dot 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 the whole square is equal to what will happen to the other side? It will be ax square plus x cube. Ax square plus x cube. Okay, now look at this. We have something the whole squared over here, right? So anyway, if I imagine this to be a single term, I will get a plus b the whole square for sure, and the remaining terms, there will be a lot of remaining terms. I literally don't care about those things. So I'll just write a plus b the whole square expansion. So p square x square plus 2px into q x squared by 2 plus q square x power 4 by 4. Plus there will be infinite number of terms, leave it, x square plus x cube. Now 2 and 2 will get cancelled. Now I am going to cut all the steps and I am going to, like what you call, make it very compact. So you can see that the right side has x square and x cube. And I can see that if I multiply these two, I think I'll write one more step. Let's make it a little bit neat. P squared x squared plus pq x cube. Okay, that will be enough, plus etc. is equal to a x square plus x cube. So you can see that if you multiply this and this, x squared will be formed, and that gives me a p square is equal to a, because here x square coefficient is a. So that gives p square is equal to 1, p is equal to plus or minus 1. See, so the derivative at the origin is plus or minus 1. And now what we do is we will multiply this and this, that will give me x cube, and if you multiply the first term and this term, we will get x cube. So a pq minus p square is equal to 1. Okay, so a into plus or minus 1 is equal to, this will become, p squared will be how much? You square 1 or minus 1, you are going to get 1. So 1 plus 1, 2. So q is equal to 2 by plus or minus a. That's it. Now I hope you remember the formula we learned long back. Radius of curvature is 1 plus first derivative the whole squared, the whole divided by second order derivative. So that will be 2 to the power 3 by 2 into a by 2. So 2 root 2 into a by 2, that will be a root 2. The next question is even more important. This is very important. Let's put it like that. So show that for the ellipse x square by a square plus y square by b square is equal to 1, the radius of curvature at the extremity of major axis is half its latus rectum. Okay, so before we start, you have to know a few things. Point number 1, latus rectum, the length of latus rectum. Latus rectum means the chord perpendicular to the major axis and passing through the focus. The length of the chord is actually 2b squared by a. You might have learned this in class 12. So half the latus rectum is b square by a. So point number 1, you must remember this. There is no other option. As an engineering student or as an engineering first semester student, the person who made the syllabus believes that students have learned this in plus 2. Okay, So to prove that radius of curvature is nothing but b square by a. Okay. Now the radius of curvature at which point? Extremity of the major axis. Now you think about it. The extreme points of the major axis means they are the vertices. And what are the vertices? Plus or minus a comma 0. So let's start. So we have x square by a square plus y square by b square is equal to 1. Differentiating with respect to x, we get 2x by a squared plus 2y dy by dx by b square is equal to 1. No, it's equal to 0. So simplifying, we will get dy by dx is equal to minus b square by a square into x by y, isn't it? So you know the formula is 1 plus dy by dx the whole square, the whole power 3 by 2 by d square y by dx square, right? At the required point. Now look at this. At the required point means it is plus or minus a comma 0. It can be a comma 0, it can be minus a comma 0. Now just imagine what happens when the denominator becomes 0. The derivative will become infinity. So in such cases, when the derivative becomes infinity, you don't have to worry. The radius of curvature is given by 1 plus dx by dy the whole squared, the whole power 3 by 2, the whole divided by d square x by dy square. Because if a fraction becomes infinity, the reciprocal will become 0. So look at this. At plus or minus a comma 0, what will be dy by dx? Dy by dx will be infinity. So what will be dx by dy? Dx by dy will be 0. Okay, now I am going to write dx by dy is equal to minus a square by b square into y by x. So please write differentiating with respect to y, d square x by dy square is equal to minus a square by b square is a constant. Then we apply quotient rule. Denominator derivative of y is 1 because we are differentiating with respect to y, minus numerator into dx by dy, but dx by dy is 0, the whole divided by denominator square. So at the required point, what will be the second order derivative? Minus a square by b square into these two this will become 0, this will become 1 by x. 1 by x means 1 by plus or minus a, that's the convexity and concavity. So basically it will be a by b square. Now let's plug it into the formula. Rho is equal to 1 plus 0 the whole power 3 by 2 by a by b square. So that will be b square by a, that is half the lattice rectum. I went a little bit fast, so you can pause the video and check it once more. So I'll tell you the main point. Here what happened is, at the required point you got infinity. So no need to worry. Just write the formula 1 plus dx by dy the whole square the whole power 3 by 2 by d square x by dx square, because we know the reciprocal of infinity will be 0. Okay. Now the last question of this group, please write. Find the radius of curvature of the curve y is equal to x square times x minus 3. Whenever the tangent becomes parallel to the x-axis. So we are asked to find the radius of curvature whenever the tangent becomes parallel to the x-axis. Remember, slope of tangent is dy by dx, and when a tangent is parallel to x-axis, dy by dx will be 0. You have to know this. You learned this from class 11, maxima minima. So whenever a tangent is parallel to the x-axis, you have to remember dy by dx is equal to 0. See, If dy by dx equal to 0, you don't have to worry, you can use the original formula. But remember, this numerator part will become 1. So our radius of curvature will depend completely on the second order derivative. Anyway, let's go ahead and find the points. So y is equal to x cube minus 3x square. So dy by dx is equal to 3x square minus 6x. D square y by dx square is 6x minus 6. Okay, now if dy by dx is equal to 0, why am I equating to 0? Because it is given that 3x into x minus 2 equal to 0. So x equal to 0, x equal to 2. Now at such points, the second order derivative is, so if x equal to 0, second order derivative is minus 6. X equal to 2, second order derivative is 6 into 2, 12, 12 minus 6, 6. Okay, time to write the formula. Radius of curvature for the first point is 1 plus 0 the whole power 3 by 2. Why 0? Because tangent is parallel to x-axis. Means dy by dx equal to 0. So that will be minus 1 by 6. And here we get 1 plus 0 the whole power 3 by 2 by 6. That will be 1 by 6. So that's it. This video is very important. Please go through the problems one by one and practice it. So I'll be back with more videos. So till then, my friends, bye.